Hello students, welcome to Math Center Web Coaching. Today we are going to see the last part of the double integrals, okay? And in this topic we are going to see how to evaluate the double integrals by changing the Cartesian coordinate system to polar coordinates, okay? Now, if you want to understand this topic, first you got to know what is Cartesian coordinate system and what is polar coordinate system, right? So let's see Cartesian coordinate system first, okay? So this is x-axis, this is y-axis, and this is origin, okay? So this is 2D plane, two-dimensional plane. Now in Cartesian coordinate system, any point can be expressed in the form of xy, right? So this is suppose my point, and I can express that point in the form of xy. So what is x, what is y? So suppose I draw a perpendicular from that point to x-axis, then this distance is x, right? And this distance is y, right? So I'm sure everybody is familiar with this concept, okay? Now we move towards the polar coordinate system. In polar coordinate system, the polar coordinates are represented by r comma theta, okay? Now let's see what is r and theta. So this is the polar coordinate system. In this is origin, okay? This is origin, and I am taking this point with the coordinates r and theta, okay? So let's see what is r, what is theta. Now r is nothing but the distance of this point from the origin, okay? So r is nothing but the distance of this point from the origin. So this is r. And what is theta? Theta is nothing but the angle made by this line, with the initial line. This is initial line, right? So angle made by this line with the initial line represents theta. So clear? This is r and theta. So in polar coordinate system, polar coordinates are represented by r. So this is what the basic idea of this, okay? Now we move towards the actual evaluation of double integrals by changing the Cartesian coordinate system to polar coordinate system, okay? Now, before we move towards the actual examples, let me show you 3 steps. Means we are going to solve the examples by using these 3 steps, okay? So first steps, convert x and y in terms of r and theta, okay? Now we have seen here, okay? So what is our first step? Convert these x and y into r and theta. Now second step, write dx dy in terms of dr d theta. And third step, find the new limits for r and theta, okay? These are 3 steps we are going to follow. Now let's see the actual example. So before that, we have to see how to convert x and y in terms of r and theta. Okay. So for that, we are going to take the value of x is equal to r cos theta, and for y, we are going to take r sin theta. Why? In 11th and 12th standard, you must have come across with this concept, right? Trigonometric. What is that? So what is the angle of this theta? Cosine angle. Cos theta is equal to x by r, right? And what is sine theta? Y by r. Okay. From that equation, you can write x is equal to r cos theta and y equal to r sine theta. Now we move towards the second step. So what is the second step? Second step is write dx and dy or dx dy in terms of dr d theta, right? So how to find out that term? Now this is dx dy, and by definition this dx dy is always equal to Jacobian of x and x comma y with respect to r theta dr d theta. Okay, so what is Jacobian? Definition of Jacobian, we can write this Jacobian as determinant of dabba x by dabba r, dabba y by dabba r. Okay, and next dabba x by dabba theta and dabba y by dabba theta, dr d theta. This is as it is, right? Now next, what is dabba x by dabba r? By step 1, dabba x by dabba r is nothing but cos theta, right? So this is cos theta, dabba y by dabba r by this equation, y equal to r sin theta. So by this equation, dabba y by dabba r is equal to sin theta, right? Now dabba x by dabba theta. Dabba x by dabba theta with respect to theta, it is equal to minus r sine theta, and this is r cos theta, right? Now this dr d theta as it is. Okay. Now next, now by using the determinant property, it is equal to r cos square. This is nothing but r cos square theta minus, and this minus becomes plus, and it will give it will get r sine square theta. Okay. So this is nothing but r cos square theta plus r sine square theta. So it is nothing but r into cos square theta plus sine square theta dr d theta, right? So this r as it is, and this is nothing but 1. So this is dr d theta, and this is what the value of dx dy. So what is dx dy? Dx dy is equal to r dr d theta. Okay. Now we move towards the third step. So what is third step? Find new limits of r and theta. So new limits for r and theta, we have to solve the actual problem. Okay. So let's move towards the actual example. Now we see the actual example. Example says change to polar coordinates and evaluate the double integral. Double integral 0 to a integration from y to a x dx dy. Okay. So we have to convert x and y coordinates, that is Cartesian coordinate system, to polar coordinates, and then we are going to evaluate the double integral. Okay. So what is first step? First step is put x is equal to r cos theta and y equal to r sine theta, right? Now let's see the limits of the inner integral. The limits of the inner integral are y to a. Okay. So as this is in terms of y, these are the limits of x, right? So write down x is equal to y to x is equal to a, right? And these are the outer limits. Okay. Then outer limits are of y. So next, y is equal to 0 to y is equal to a. Okay. Now, next step, just we have to substitute x is equal to r cos theta and y is equal to r sine theta in these equations, right? So, by using this, now I am going to substitute r cos theta in place of this x, okay? And r sine theta in place of y. So, r cos theta equal to r sine theta, okay? Minute. Now next, this r and this r get cancelled, and this will become sine theta equal to cos theta. I take this sign here, left hand side, then I'll get cos theta divided by sine theta equal to 1, right? Now cos theta divided by sine theta is nothing but tan theta, which is equal to 1, and tan theta is equal to 1 implies theta is equal to tan inverse of 1, right? So what is tan inverse of 1? And that will give the value of theta. So what is that? Tan inverse of 1 is always equal to pi by 4. Okay. So by using this equation, we get the value of theta, that is pi by 4. Okay. Now let's see this equation, x is equal to a. Okay. Now put x equal to r cos theta. So in place of x, r cos theta, and a as it is constant. So what is r? By using this equation, r is equal to a upon cos theta. So by using this equation, x equal to a, we get the value of r, that is a by cos theta, right? Now, what is second step? Second step is dx dy. The value of dx dy is r dr d theta, as we have discussed earlier, right? Now, the third step, we need to find out the new limits for r and theta, right? So for that, we have to plot here. Okay, so this is the angle. Just a sec. Okay, so this is sorry, not angle. This is x-axis. This is y-axis. This is origin, right? Now, what are the limits? The original limits are x equal to y, x equal to a, y equal to 0 and y equal to a. These are the given limits, right? As per our equation or example. So x equal to y, that is first limit. X equal to y is nothing but the line which is passing through origin, right? So this is x equal to y. Now the second limit, x equal to a. So what is the x equal to a? X equal to a, that means the line which is parallel to y-axis, means this axis, this line, x equal to a, the equation of this line, right? Now y equal to 0, y equal to 0, that means this is the equation of x-axis, y equal to 0. And what about y equal to a? Y equal to a is the equation of the line which is parallel to x-axis, that is y equal to a, right? So these are the given limits or original limits. Now what about new limits? Now in new limits, actually we are finding new limits for polar coordinates, right? R and theta. So in this case, polar coordinates, we have to take the angular strip, okay? So now the region of integration. So region of integration is here, this one. Why? Because this region is bounded by y equal to a, x equal to y, x equal to a, and y equal to 0, all the limits, okay? So this is region of integration. Now, as we are finding the new limits for r and theta, polar coordinates, for polar coordinates, we have to take the strip which is angular, okay? So this is the strip, okay? This is angular strip. Now we have to find out the new limits for r and theta, right? Now, as you can see here, the strip goes from this point origin to this point, right? So what is the value of this here origin? Origin is 0. So this point goes from 0 to this point. That means by using this line, equation of this line, x equal to a, we get the value of r here, r equal to a cos theta. That means this strip goes from the point origin 0 to r is equal to a by cos theta, right? Because r is nothing but what? R is nothing but the distance from the origin, okay? Distance of that point from the origin. So what is the minimum distance of r? That is 0 itself, that is origin. And what is the maximum distance of r? That is a by cos theta. So the new limits for r are r is equal to 0 to r is equal to a by cos theta, right? Because this strip goes from 0 to a by cos theta, right? So to get the new limits for theta, we have to move this strip from x-axis to x equal to y, this line, right? Now, when we have solved this x equal to y equation, we got theta is equal to pi by 4, right? Here. So, what are the limits or what are the new limits for theta? Theta from x-axis, right? That means initial line, which is equal to, okay, 0. So from theta varies from 0 to pi by 4, right? 0 to pi by 4. So this strip goes from 0 to a by cos theta and moves from 0 to pi by 4, okay? So this is the limit for theta, so which is 0 to theta is equal to pi by 4. So these are the new limits, okay? So these are the new limits for r and theta. Now, next, just we have to substitute these new limits in our star equation, or you can say in the given example, and then the given example becomes, let me write, it will become 0 to pi by 4, 0 to a by cos theta. Now 0 to a by cos theta, these are the limits for r and this is the limit for theta, right? Now what is our example? X cos x dx dy, right? Now in place of this x, we have to substitute x is equal to r cos theta. And what about this dx dy? The dx dy, value of this dx dy is equal to r dr d theta, right? So just substitute that value and we'll get, in place of x, I'm going to write here r cos theta and r dr d theta. And for dx dy, I'm going to write r dr d theta, right? Now, this integration, outer integration from pi by 4, 0 to pi by 4, 0 to a by cos theta This is as it is. Now this r and this r becomes r square cos theta dr d theta, right? Now we have to integrate this, and as per the rule, we have to observe first the limits of the inner integrals. Okay, so here the limits of the inner integrals are 0 to a by cos theta. That means this is in terms of theta, right? So we have to integrate first with respect to r. Okay, at the same time we have to keep theta as a constant, right? So mention here. So let me mention that integrate with respect to r first, sorry, r first, and keep theta as a constant, right? So by using this integration from 0 to pi by 4, this outer limit remains as it is. Now as we keep theta as a constant, this cos theta is a constant term, right? So we have to take that constant out of this inner integral. So this is cos theta, okay? Integration from 0 to a by cos theta r square with respect to dr. Now I put bracket over here, okay, just to understand you. Now next, this d theta as it is. Now the next term, outer integral pi by 4, this is as it is, cos theta as it is. Now we have to integrate this bracket, right? Now r square, the integration of r square is r cube by theta, r cube by 3, right? Limits 0 to a by cos theta, and this d theta remains as it is, okay? So what is next step? Next step, just we have to substitute limits, okay, in place of r. So upper limit minus lower limit. So integration from 0 to pi by 4 as it is, cos theta as it is. Now substitute the limits, upper limit a by cos theta in place of r, okay, and r cube. So this will become a cube upon 3 as it is, this 3, and cos cube theta minus, in place of r we have to substitute 0. So this will become 0 only, and d theta as it is, right? Now the next term, integration from 0 to pi by 4, outer limit still remains as it is, cos theta as it is, okay? Or you can say that you can cancel this term, right? This is as this is 0 term, so you can write a cube by 3 into cos cube theta d theta, okay? Next, you can cancel this cos theta with respect to this cube, right? So we'll get integration from 0 to pi by 4, sorry, into a cube divided by 3 into cos square theta d theta, right? Okay. So what is next? Now we are going to integrate with respect to theta. Okay. Now in this case, a cube and this 3 are constant. Okay. So you can take that constant outside this integral sign. So I can write a cube by 3 integration 0 to pi by 4 1 upon cos square theta d theta, right? Now next, what is cos 1 upon cos square theta? Is a cube by 3, this constant as it is. Now integrate this term, okay, with respect to theta, okay? So what is that bracketed quantity? 1 upon cos square theta is nothing but sec square theta, right? So sec square theta is equal to, so integration of 0 to pi by 4 theta d theta, right? Now take integration. So what is the integration of sec square theta? So this is equal to a cube by 3 as it is, okay? So sec square theta is equal to tan inverse of theta, okay? Where the limits are from 0 to pi by 4, okay? So next, a cube by 3, this constant as it is. Now put the upper limit minus lower limit. So what is upper limit? Pi by 4. So tan inverse of pi by 4 minus tan inverse of 0. Okay. Next, A cube by 3, constant term still remains as it is. Now what is the value of tan inverse of pi by 4? Which is equal to 1, and minus tan inverse of 0 is 0. Okay. So what is the last value? So last example answer is a cube by 3. So this is the last answer. Okay. So I hope you can understand this example very well. Just remember the 3 steps when you are going to solve such examples. Okay. First step, as we have discussed here, okay, convert x and y into r and theta, write dx dy in terms of dr d theta, and find new limits for r and theta. Okay, in this example also, first we convert this x and y in terms of r and theta. That means we put x equal to r cos theta and y equal to r sin theta. Okay, and what about the second step, dx dy? We put dx dy is equal to r dr d theta, right? And then we find out the new limits by using this, okay, angular strip, and substitute that new limits. After substituting that new limits, we'll get the last answer. Okay. I hope you can understand this example. In next session, we are going to see the new topic. Okay, thank you.